Okay, we are looking at the backside of 2.6 practice. Number 4 gives us the following information. Angle A is complementary to angle B, and angle C is complementary to angle B. So what do we know based on this information? Now, let's look at this. This is basically the same exact example. Get rid of this. If A is complementary to B, so these add up to 90, and C is complementary to B, so those two add up to 90, what do we know about angle A and angle C? We know that they should be the exact same measure, which is to say that they are congruent. So write something of that sort. Angle A is congruent to angle C. Their measures are equal. Cool. And that's by the congruent complements theorem. In case you're trying to explain your reasoning in a different way than congruent complements theorem, maybe you can use numbers, actual numbers, hypothetical numbers, to explain your reasoning as to why angle A is congruent to angle C, or that their measures are equal. Now this says if the measure of angle A is expressed as 3x plus y, we also have an expression for the measure of angle B and for the measure of angle C. This says set up and solve a system of equations to find the value of x and y, and then to find the measure of angle B. So my desire is that you guys can actually set up a couple of equations based on the information we just talked about. But furthermore, I think you should be practicing these systems of equations, because this isn't the last time you'll see them. You will continue to see systems of equations. You can get really good at them, but you have to practice. So before I continue, you should actually try this out. Set up some equations that are true based on the information we're given. So pause the video. Okay, we know that the measure of angle A is equal to the measure of angle C, so I can write this statement, and I'll just highlight. Right, we know that these are equal, like we previously stated. So let's just set these equal to each other. Good. Now, we can consider the fact that A is complementary to B, or that C is complementary to B, to set up another equation. You should know complementary. What does complementary mean? It means two or more angles whose sum is 90. So you add them up to equal 90. So let's just go with A and B. So I'm going to write 3x plus y plus x plus 4y plus 2 equals 90. Okay, this is a system of equations. I have two or more equations with two or more variables each. So we have a few different methods we can use in solving these. We can use substitution, elimination. We could even graph. We can solve by graphing. But graphing would be a little bit too much work, I'd say, in this case. So let's start out by simplifying these equations and figure out if we want to do elimination or substitution. So I'm going to move my x's and y's to one side of the equation. So I subtract 3y from both sides. I should get 3x minus 2y equals negative 3. Okay. This is in standard form, by the way. This is just a linear equation in standard form. This kind of more prepares me for elimination. Okay, this one, let's combine like terms. So 3x plus x is 4x, 4y plus y is 5y, and then let's subtract 2 from both sides. Okay, now that I have these two equations both in standard form, what I want to do is I'm going to eliminate. I'm going to try elimination, which means I need to get the coefficient either on the x's the same or the coefficient on the y's exactly the same. They're clearly not the same in this case. So I can manipulate these equations in whatever way I wish. I can multiply an equation by any number I want, as long as I multiply it to every term. I can divide any of these equations by anything I want. I can even add or subtract equations from each other. I think the most typical way in which people solve this is they just start out by trying to get the same coefficient on, let's say, x. Right now we have 3 and 4. So if I want to get the same coefficient on these, I'll multiply them by the coefficient on the other equation. So for example, 3x minus 2y equals negative 3. If I multiply this by 4 and distribute, and do the same thing with this one, 3 times 4x is 12x, 3 times 5y is 15y, and then 3 times 88, that's 240 plus 24, so 264. Okay. Now I have the same coefficient on my x and my y. So with that, I can subtract one equation from the other. So I'm going to rewrite this one below the other one. So I'm going to say 12x minus 8y, and then this is negative 12. Let's be very careful when we're subtracting one from the other when we deal with the subtraction of a negative. So 12x minus 12x, there's our elimination part. Good, we've eliminated the x's, so now we only have a y in the equation. And then we can solve much easier. 15y minus negative 8, so 15y plus 8 is 23y. 264 minus negative 12, that's 264 plus 12, which will give us 276. And now this is quite easy, right? This equation is much easier to solve. Let's do 276 divided by 23. We find out that y equals 12. Awesome. Now it's quite easy to find the value of x. Since I have the value of y, I can plug it into any of these equations that I'd like. Maybe I'll plug it into this one. This one's probably the simplest one to do. So I'm going to do 3x minus 2 times, well, y equals 12, so I'm just substituting in the value of y for where we have y written in our equation. So we have 3x minus 24 equals negative 3. If I add 24 to both sides, I get 3x equals 21, and we get a nice number. Divide both sides by 3, you get x equals 7. Now, remember this question's asking for the measure of angle B. We already got x, we already got y. Now we need to find the measure of angle B. Well, they tell us that the measure of angle B is, and you can see it right here, x plus 4y plus 2. What's the value of x? You know the value of x is 7, so I'm just substituting. Plus 4 times y is 12, plus 2. If we simplify this, looks like we get 57 degrees. Cool. Alright, let's do one more. We got this proof here, number 5. Angle 1 is congruent to angle 2 as our given information, so make sure you write down that given information. And we're trying to prove that angle 1 is supplementary to angle 3. So just a rough sketch of what's going on here. We already know that angle 1 is congruent to angle 2. And if we look at this drawing, this diagram, we see that angle 2 and angle 3 form a linear pair, which means they're supplementary, which means the measure of their angles add up to 180. Now if these two add up to 180, then 3 and angle 1 should also add up to 180. So how do we break this down? Well, I'm going to first break down this information using the definition of congruence, because this is going to allow me to later substitute. Now if you didn't do this as your next step, don't fret. You do not have to do a proof in one specific way. Okay, by definition of congruence, we know that's true. Now I'm going to point out via the diagram. So I'm going to assume from the diagram one of the few things I can assume from a diagram. That is, that angle 2 and angle 3 form a linear pair. Now, since we have that information, we can use the linear pair postulate to state that angle 2 and angle 3 are supplementary, because that is what the linear pair postulate tells us. So, since they're supplementary by definition of supplementary angles, we know that the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Now here's where what I wrote earlier comes into play. I know that the measure of angle 1 equals the measure of angle 2. So I'm going to substitute, and we can only use substitution in this case. We cannot use the transitive property here. Substitute. Substitution. I'm going to write the measure of angle 1 plus the measure of angle 3 equals 180. Okay, so let's highlight this in blue so you guys can see clearly the substitution. Now we're technically done, right? The measure of angle 1 plus the measure of angle 3 equals 180. So by definition of supplementary, we know that angle 1 is supplementary to angle 3. So I'll give you a quick view of this in the diagram. What we were given was that angle 1 is congruent to angle 2, as well as the diagram. Now let's just say angle 2 is 130 degrees. If angle 2 is 130 degrees and angle 1 is congruent to it, we should know that angle 1 is also 130 degrees. But we also know from the diagram that these are a linear pair, so they're supplementary, so we know they add up to 180, making the measure of angle 3 to be 50. So the whole point is angle 3 is clearly supplementary to angle 1, right? Because 50 plus 130 equals 180. So those are just hypothetical numbers, but it's to point out that it is the case, no matter what those numbers are, that angle 1 is supplementary to angle 3, given the information we were given.